function is there, how we will find the modulus of that function, right? So suppose any type of function is given, like sin x is given. So graph of sin x is like this. So to find modulus of this sin x, right, what we have to do, every time whatever function is given below this line, below this x axis, right, all these part below this x axis we have to remove. Each part we have to remove, we have to cut, and same part whichever given below x axis we have to draw. Just we have to take reflection of that graph whichever is given below x axis. So the final graph will look like this, right? Got it? This is the graph of mod of sin x. Now just see, we have to find out mod of this box x. That means whatever function is given below x axis, we have to copy that function. We have to take reflection of that function with respect to this line, that is x axis. So now if you take reflection here, you will get this function here, this curve here. So again you will get this curve here, right, like this one. So actually this is the curve for this function, modulus of box x, right? So modulus of box x and modulus of this function, the graph will look like this. First this one, second this one, third this one, and the rest graph will look like this, like this one. This is the graph of box modulus of box x. Got it? We have to remove the portion which is given below x axis. After remove, take reflection of that graph, right? Also you can say just take reflection of that graph with respect to x axis to find modulus of any function. Any doubt? No, this is for modulus x. Now next one, this box of modulus x, right? So modulus x, mod x means it is x for x greater than equals to 0, it is minus x for x is less than equals to 0. This is called mod x, right? Now we have to draw the graph of modulus of box x. Now we have to put box here. So again, that means we are putting box here. We are putting box here. So for positive values of x, this will look like same, like previous one. So it will look like same, like previous graph. For positive x, for this one, right? Now for negative values of x, like this. For if values of x are negative, right, like this one, then you have to take modulus of this number, right? Any doubt? Let me know. Up to here, any doubt? Am I audible?
Yes, sir. Yes, sir.
Now you all can turn on your camera. Okay. If again meeting get disturbed, then turn off camera. Like while turning on camera, this meeting takes more data. It needs more data because it is sharing video also, right?
How are you able to blur your background, sir?
Is there any doubt? No, first tell me for this one. Is there any doubt in this function, graph of this function? There is no doubt. right? See, I can show you the graph also. You want to check the graph on any, there is a website. Okay, there also you can check.
Ah.
Like in the class also I told you, if you want to graph of any function, you can just write down there, you will get the graph. So there is concept also. If you want to get the graph of any modulus function, any type of modulus function, like you can draw the graph of mod x also, as you know. So this is the graph of y equals to x. This is the graph of y equals to x. And here, this is graph of y equals to x. Now we want to find the graph of y equals to just putting mod x here. Right? How will you get? So whatever portion is given below x-axis, take reflection along y-axis. Sorry, along x-axis. So reflection you will get like this. Right? This side no graph is given below x-axis. So graph will remain like this one only. So overall graph you will get graph of mod x will be like this. This is the graph of mod x. Right? Arun, any doubt? Anyone?
No, sir, I can understand.
Okay. So similarly, I have drawn this graph here. Right? Now we are going to draw graph of this function. What about this box of minus x? What will be the graph of this minus x? So if I put here values of x is negative. So negative, this will become positive. Right? If I take here any negative value for x, so this will also become positive number. For negative x, that means mod x is always a positive number. For positive x, for negative x, this will be always a positive number. So how the graph will look like for this one? Just draw it here. So same as previous one. That means for negative graph, I am taking here positive. See, x is negative, but just by putting values of x here negative, this minus will become positive. Right?
Yes, sir.
If I suppose this is -1, if I put here 0.5, minus 0.5 here. If I put in this function, in the box of minus x, if I put x equals to minus half, so we will get half. And box of half is 0, right? You will get same curve here. So I am using different color pen. You will get same this one. Right? Now again, if
Yes,
I
sir.
take x equals to minus 3/2, or you can take integral values also. Right? If I take x equals to -1, so just put x equals to -1 here. So this will become 1. Box of 1 is 1. Right?
Yes,
So here suppose this is 1. So you will get box as 1. Like this. So graph will continue like this.
But
This side failed, this
going
side
on in the negative side, sir, it is like we are getting only one answer.
see. Here it is written, this is mod.
Hmm.
Right? Here I'm writing here mod. So mod x can be written as either mod x can be opened with minus x or plus x when x is positive, when x is negative. Right? This is correct. Now we are putting box on this x.
Yes.
Now this also, here also we have to put box, here also we have to put box.
Hmm.
Right? So in this box also
Yes,
we
sir.
have positive value. In this box also we have positive value. If I take any value which is less than 0 and that value if I put here, so minus will become positive because one extra minus is there. I am putting negative value here, so that minus this will become positive. Right? This thing is there. So as you can see, the same graph is given. Just we are taking reflection on both sides. Right?
Okay, sir.
So there is, so just first copy this one. These two graphs are very important. Okay. These are the two graphs. Now we will check the options. What options are given in the question? So here, what are the values of x for which this g of f of x is less than or equals to f of g of x? Now we have to compare the graph, and we have to find the value for which, as you can see, both are looking almost same, not exactly same, but almost same. So where f of, now we have to do one thing. We have to draw both graph in one Cartesian plane. Then we can get which graph is above, then which graph. Right? So above one graph will be the answer because it is given greater than equals to 0 in the question. Yeah, less than. Okay, less than equals to 0. Now let's draw on the same Cartesian plane. This is the Cartesian plane, and first graph I'm drawing with this color pen. So this is first graph. It's like this. Now let's draw second graph. Second graph, both side it is same. This side it is same. This side it is same. Both graph, right hand side of both graph is same. Right? So for x greater than equals to 0, for x greater than equals to, both are equal. Both functions are equal. Right? So this will be our answer. X will be x greater than equals to 0. Now for right hand side also we have to check what is the solution. So here this will be, I'm using different pen with the same pen. This one. This was the graph. Right? Here this is this last portion, that is -1. -1 is not included in yellow line. Right? So here for -1 you will get, it will start from here. So this filled circle to open circle. Right? Again next graph will start. As you can see in this graph, this portion is filled. This here we have filled circle. Here also we had filled circle. Here also we have filled circle. One side unfilled, one side filled circle. No, here it also in the yellow line graph we have filled circle here also. Right? Open. Like this. So this graph to open. This side open circle. So tell me the values of x for which both are equal on the right hand side graph. Only at integers. If you take -1, both functions have same value. If you will take -2, so both have same. They are intersecting at one point here. See here. The question is for which, here in this region, in the second quadrant, which graph is above and which graph is below. Tell me. Here in the first quadrant, both are same, exact overlapping. So on the second quadrant, which graph is above, which graph is below? Like if we observe only between 3 to 2. If we observe between 3 to 2, suppose we are observing between 3 to 2. So which graph is above, which graph is below? So the pink one is above, then yellow one. Right? That means the pink function is always greater than this yellow one. Right? Again, between -2 to -1, pink one is greater than yellow one. Right? From -infinity minus infinity to 0 is also the solution. And